I received this graphic card today in the postage from a customer for repair. It's a Beast 980 Ti, but look, it's overdone. Yeah, I repaired many 980 Ti's, but I never have such one. To me, it's so I think it will be a custom. It's look very custom PCB. So let's take it apart and have a look. The customer didn't explain what's wrong with the card. Yeah, it's look, there is a screw missing here. Screw from this side is missing. Some surprise. All this beef heatsink it's all attached only to the GPU screws. That's, I feel it's not a good idea. Put the heatsink aside. So let's have a look. Yeah, it's totally custom PCB. Let's take the back plates. I want to have a thorough inspection on the card from both sides. At least they should include a couple screws from this side to support the heatsink. But I don't blame, it's Zotac. Oh, this is nothing, no thermal pads on the back, as you can see. Yes, that's power boost circuits. I'm still not sure what's that, the inclusion of that circuit. It's look like an additional PCB added on the top. Sometimes these stuffs make things harder. If there's issue in the inside there, taking it apart and put it back again make things complicated. And you can see there's a fiddling to repair this card, which I usually don't like to get such a card, because you don't know what modification and what's done to this card before, which make it very hard. What was the original problem and how to repair it. As to be honest, I have experience, a good experience with repairing cards which have natural problems that happen, burn components, corrupting BIOS, dead chips, shortage, anything. But when people fiddle with these cards, it's sometimes you can't tell what's going on. But I think that's the only thing. I think I can tell most of the soldering is factory. Yeah, I'm just suspecting these two inductors. That's the memory rail. This is the GPU power MOSFETs. I think that's the controller of the GPU, yes. And we got here, I think, the BIOS chip. Yeah. Hynix memory. So let's start. But look, to me, it's been reheated, as you can see here. There's a flux around, which is never, and there's a patches of flux left here, which they don't know how to clean it. So bad to leave any flux. So I think it's reflowed or reballed. I can't tell. I can tell very easy that thing's been reflow or reball, but it's not put in the oven. And it looks like it's done thoughtfully because the flux is not everywhere on the card surface. Yeah. So such issues, it's hard to repair, because with this experienced people, they just heat the chips randomly and cool it, even if they don't pass the critical temperature to kill the chip. But what's happened, they just put it in oven or just put a heat gun, even if they have thermostat. Because to be properly done, the reball and reflow, you need a profile. You need certain temperature to certain temperature, first reaching certain temperature, which make it become steady until the whole boards heat up, especially from the bottom, which help the solder to melt. And then a certain temperature range and time to start the flux to work on, because that's when the flux start activated. And then from that temperature, it's need a short time to get to the maximum for solder melting, and it's different from lead-free solder to leaded solder. And you shouldn't cross a maximum time for that, otherwise you kill the chip. And then cooling down also, you shouldn't go very fast with cooling down back to normal, because that's make a lot of contraction expansion issues between the chip and the substrate of the chip, and between the substrate, the whole GPU, and the PCB. That's all sudden and shock changes in expansion and contraction. Even the PCB, because it's multi-layer and have a lot of layers of copper connection, cooling very fast or heating very fast or to certain temperature, there is a lot of bowing on this board. I can see from the side there is a lot of curvature happen to this board. So that's also cause internal connection, which is, you see how tiny they are, and the very, very thin strips of copper, they just break apart because the board is bending to compensate for cooling and heating quickly, which cause this connection to break apart. And people don't realize, they just okay, I will apply heat, try to fix it myself. Okay, so let's go with the diagnosis and check first the resistance all over the board, see what we have here. So That's ground. All over any coppers on the board is ground. So it's visible. Okay. So first let's check the 12 volt. It's normal. 3.3 volt is normal. Let's check the V core. This inductor doesn't have connection from this side, so I have to go first with the 12 volt rails. Perfectly normal. They usually this rail up and then they just jump to mega ohm, or you see high kilo ohm. They starting from 3, 4, 5 and then poof, they jump to 60, 70 or sometime in mega ohm. You see this is 1.5 because the capacitor is charging and the resistance just go up. So there's no short there. That's the PIX rail, I guess, because this is custom board, but it's still a good resistance. It's not too low. I was wishing for this is not 700, 800 kilo ohm. 0.7, sorry, 0.8 kilo ohm, about 700 ohm. And let's see the memory, which is the critical things on this card. And it's good. The memory is reading 75 ohm. That's mean we got a healthy memory and memory controller, because this rail, when it's die and passing any 12 volt to the memory, most of memory die, which is easy to replace and purchase new ones. But the GPU memory controller, which is located here on these sides, on the edges, which is all these capacitors read the memory voltage, it's die when it gets 12 volt passed to it, or more than 1.5 volt, what that's suggested to be, or 1.6 maximum for certain types of memory. But if it's go higher, that's it's gone. Yeah, no point for repairing. I think this is also 12 volt rail or 5 volt. Yeah, it's 5 volt. This regulator is linear regulator. It's still okay, not too bad. And this power systems looks to me this have high low size MOSFETs and the drivers and the controller, the main controller. So let's have a look on the back of the board. Yeah, the back is just caps, resistors, and oscillator is on this side, which rarely have issues or cause any issues. Rarely. Yeah. Okay. So I'm going to stop the video and continue when we connect the board to a computer for testing.